projects. In this video, we are going to explain about the project title Wild Bird Species Identification based on a lightweight model with frequency dynamic convolution. Introduction. Bird species are integral to the ecosystem, contributing unique melodies to nature's symphony and serving as crucial indicators of environmental health. Their presence, absence, or behavior can signify changes in habitat conditions and ecosystem dynamics, making them invaluable for ecological monitoring and conservation efforts. Existing convolutional neural network CNN models, while powerful in their ability to extract features from data, pose challenges for deployment in field environments. The large number of parameters and complex calculations make them computationally intensive and impractical for use in real world settings where resources may be limited. The project addresses the limitations of current CNN models by developing a lightweight alternative using frequency dynamic convolution. This innovative approach provides a practical and efficient solution for identifying wild bird species, enabling researchers and conservationists to gather crucial data for ecology and conservation research. Through the implementation of frequency dynamic convolution, the developed model enhances feature differentiation across frequency bands in bird sounds spectrograms. This allows for more accurate capture of the unique characteristics of bird calls, improving the model's ability to distinguish between different species based on their vocalizations. Objective. The project seeks to transform the field of bird species identification by introducing an innovative approach that utilizes frequency dynamic convolution and lightweight models. This method offers significant advantages over traditional visual-based methods, particularly in challenging environments such as dense habitats or adverse weather conditions. By leveraging advanced technology, the project aims to provide a more accurate and efficient solution for identifying bird species. Through the accurate identification of bird species based on their sounds, the project aims to generate valuable data that can be utilized for population ecology and conservation biology research. This data is essential for understanding bird populations, their distribution patterns, and their interactions with the environment. By providing researchers and conservationists with accurate species identification tools, the project contributes to informed decision making and conservation efforts. The primary objective of the project is to develop a lightweight model optimized for deployment in field environments. This involves reducing the model's parameters and complexity while maintaining high accuracy in bird species identification. By creating a model that is efficient in terms of computational resources and suitable for deployment in real world settings, the project aims to overcome the limitations of existing model and provide a practical solution for ecology and conservation research. The integration of the coordinate attention CA mechanism further enhances the model's ability to extract comprehensive global information from bird sound data. This mechanism complements local feature extraction by capturing broader contextual relationships within the data. By incorporating advanced attention mechanism, the project aims to improve the model's overall performance and accuracy in identifying bird species based on their sounds. Software and hardware requirements. Hardware requirements of the project are operating system of Windows, processor of Wi-Fi and above, RAM of 8 GB and above, hard disk of 25 GB and above. Software requirements of the project are application is Anaconda, primary language is Python, front-end framework is Flask, back-end framework is Jupyter Notebook, database is SQLite 3, and front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Working modules or flow of work. To implement this project, we have designed the following modules. The first module is importing the packages. This module involves importing all the necessary libraries and packages required for the project. These include libraries for data manipulation, model building, training, web development, database management, and any other relevant functionalities. Exploring the dataset. The dataset containing bird sound recordings is explored. This involves loading the dataset, examining its structure, and understanding the features present. Exploratory data analysis techniques are applied to gain insights into the data, such as visualization of sound spectrograms or statistical summaries. Dataset pre-processing. This module encompasses several steps to prepare the dataset for training the model. Shuffling. The dataset is shuffled to ensure that the order of samples does not bias the model during training. Splitting the data to train and test. The dataset is divided into training and testing subsets. The training data is used to train the model, while the testing data is used to evaluate its performance. Additional pre-processing steps include data normalization, feature extraction, or data augmentation techniques to enhance the model's performance and generalization ability. Building the model. This module involves defining the architecture of the lightweight model with frequency dynamic convolution for bird species identification. The model architecture specifies the arrangement of layers, including convolutional layers, pooling layers, attention mechanism, and any other relevant components. This step lays the foundation for training the model on the bird sound dataset. Training the model. Here, the defined model is trained using the pre-processed training data. The model learns to identify bird species based on the features extracted from the sound recordings. Training involves iteratively adjusting the model's parameters to minimize the chosen loss function and improve its performance on the training data. The training process includes multiple epochs, batch processing, and optimization techniques such as gradient descent. Flash framework with SQLite for sign up and sign in. This module integrates the Flask web framework with SQLite database management system to create a user authentication system for sign up and sign in functionalities. Users can register their accounts, sign up, and log in to access the application sign in. The SQLite database stores user information securely, enabling authentication and authorization processes. User gives input, and the given input is pre-processed for prediction. User input, such as bird sound recording file, is collected from the front-end interface. The input data undergoes pre-processing, similar to the pre-processing steps applied to the training data to ensure compatibility with the model's input requirements. This involves extracting features from the sound recording and formatting them appropriately for prediction. Trained model is used for prediction. The pre-processed user input is passed to the trained lightweight model for prediction. The model applies its learned knowledge to the input data and predicts the bird species present in the sound recording. This prediction is based on the model's understanding of the features associated with different bird species learned during the training process. Final outcome is displayed through front end. Finally, the predicted bird species outcome is displayed to the user through the front end interface of the application. The user receives feedback on the bird species identification, facilitating further analysis or actions based on the predicted outcome. This completes the workflow of the wild bird species identification project, providing users with an efficient and user-friendly tool for identifying bird species based on sound recordings. Algorithms used to implement this project, we have designed the following algorithms. The first algorithm is propose lightweight model. The proposed lightweight model is tailored specifically for bird species identification based on sound recordings. It incorporates techniques such as frequency dynamic convolution, which allows the model to capture temporal and spectral features of bird sounds effectively. By focusing on relevant frequency bands, the model can differentiate between different bird species based on their unique vocalizations. Additionally, the lightweight model is designed to have fewer parameters and lower computational complexity compared to traditional CNN architectures like ResNet 50. This makes it more suitable for deployment in field environments where computational resources are limited. The model also includes attention mechanism such as coordinate attention (CA) to improve its ability to extract global information from the input spectrograms. This attention mechanism helps the model focus on important regions of the spectrogram while suppressing irrelevant noise, leading to more accurate classification results. Coming to the next algorithm, which is existing ResNet 50. ResNet 50 is a deep neural network architecture that consists of 50 layers, including convolutional layers, pooling layers, and fully connected layers. It is renowned for its effectiveness in image classification tasks thanks to its deep structure and residual connections. Residual connections allows gradients to flow more easily during training, mitigating the vanishing gradient problem commonly encountered in deep networks. This enables ResNet 50 to be trained effectively even with a large number of layers. However, ResNet 50 may not be well suited for bird species identification based on sound recordings due to its high computational complexity and large number of parameters. In contrast, the proposed lightweight model is specifically optimized for this task, offering improved efficiency and accuracy in classifying bird species from audio data. As an extension, we have built ensemble models by combining the predictions of multiple individual models to produce a more robust and accurate final prediction. Also, as an extension, we built front end using Flask for user testing with authentication. Comparison graph offer a visual breakdown of how our models perform across essential evaluation metrics. Models are compared with the performance metrics accuracy, precision, recall, and FN score. This is the accuracy comparison graph. On the x-axis, we have accuracy score, and on the y-axis, we have algorithm name. Accuracy is a measure of the overall correctness of a classification model. It calculates the ratio of correctly predicted instances, both true positives and true negatives, to the total number of instances. This is the precision comparison graph. On the x-axis, we have precision score, and on the y-axis, we have algorithm name. Precision is a metric that assesses the accuracy of positive predictions made by the model. It calculates the ratio of true positives, correctly predicted positive instances, to the total number of positive predictions, true positives plus false positives. This is the recall comparison graph. On the x-axis, we have recall score, and on the y-axis, we have algorithm name. Recall, also known as sensitivity or true positive rate, measures the model's ability to correctly identify all relevant instances in the dataset. It calculates the ratio of true positives to the total number of actual positive instances, true positives plus false negatives. This is the FN comparison graph. On the x-axis, we have FN score, and on the y-axis, we have algorithm name. FN score is the harmonic mean of precision and recall. It is a balanced measure that considers both false positives and false negatives. It is calculated as 2 times the product of precision and recall divided by the sum of precision and recall. It provides a single metric that balances precision and recall, making it useful when we want to consider both false positives and false negatives in the evaluation. Execution. To execute this project, first we need to open the code folder, which contains the project source code files. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, and more, which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. So here I'm copying the path. Now open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. So here I'm typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, which is this, and port, which is this. Now copy this local link provided by the Flask framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. If we are a new user, we need to register first. So click on sign up button here. So here we need to enter all these details to register. But I have already registered, so click on sign in link here. So here we need to enter the username and the password which we have registered. And then click on sign in. We have logged in successfully. So here we need to upload the audio file and the application will predict the type of bird. Click on choose file to upload the audio. I'm selecting the first audio. Now click on upload button. So here we can see the result. Given audio sound predicted for bird species is Chinese bulbul. Let us upload some more audio files. Click on choose file. Click on upload. Given audio sound predicted for bird species is magpie. Let us upload one more audio. Click on open. Now click on upload button. Given audio sound predicted for bird species is sparrow. In this way, just by uploading the audio file of the birds, we can predict the type of bird. Now click on sign out button. Conclusion. The conclusion of the project highlights the pivotal role of lightweight model with frequency dynamic convolution in advancing bird species identification for ecological and conservation purposes. By leveraging innovative techniques such as frequency dynamic convolution, the model enhances the accuracy and efficiency of bird species identification, contributing to the understanding and conservation of avian biodiversity. By successfully addressing the limitations of traditional visual based methods, the project introduces a novel approach that leverages sound recognition technology for bird species identification. This innovative method offers significant advantages over visual based methods, particularly in challenging environments, and represents a significant step forward in bird species identification research. The project underscores the importance of accurate bird species identification in population ecology and conservation biology research. By providing valuable data on bird populations, distributions, and behaviors, the developed model contributes to informed decision making and conservation efforts aimed at protecting avian species and their habitats. Integrating a user-friendly Flask interface with secure authentication enhances the overall user experience during system testing and deployment. The Flask interface provides a convenient platform for users to input data and interact with the system, while secure authentication measures ensure data privacy and integrity. This user-centric approach improves the usability and accessibility of the system, facilitating its adoption and use in real-world applications.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.